Alright, let's start solving quadratic equations. Before we do that, I want to look at foiling when we multiply out binomials. When we do that using the first, outside, inside, last. So we're going to multiply together the two first terms, and we'll get x squared. Then the outside terms, and we get 5x. Insides give us 4x. And lasts give us 20. To finish this process up, we should combine like terms. So that's going to be these two, the 5x and the 4x, and we'll have x squared plus 9x plus 20. I'll try and be a little bit faster with this. X times x will give us x squared. And then our outsides and our insides. The outsides will give us negative 7x, and the insides will give us 3x. So negative 7x plus 3x is negative 4x. And then finish it up by doing the last. 3 times negative 7 is negative 21. There are a couple of special products that we like looking at because it kind of makes life a little bit easier. First of all, the difference of two squares. If we FOIL this one out, we do first and outsides, and we'll do insides and last. What we notice about the two middle terms is because we'll have a plus 4x minus 4x thing happening, those two are going to cancel out. And our special product is going to be the difference of two perfect squares, x squared minus 16. If we have a perfect square, the most common mistake that everybody makes is distributing the power over addition. And that's not a thing. We can't just go x squared plus 25 and call it good, because that's not what it is. What we need to do is FOIL it out. And we'll have x plus 5 times itself, x plus 5. The firsts give us x squared. The outsides give us 5x. The insides is another 5x. And the last give us 25. Simplifying the two terms that are in the middle, we get x squared plus 10x plus 25. We wanted it to be x squared plus 25, but that's not the case. Anytime that we have a perfect square, we're going to have this middle term that's twice as big as the product of each of the individual terms. So if we multiply them together, we get 5x, double it. That's how we get the 10x in the middle. What we notice from multiplying out a bunch of binomials is that we'll always end up with this thing happening, where in the middle, the coefficient of this linear term is just going to be the sum of the two constants. And the last term is when we did the lasts, and that's when we multiplied m and n together. Because now what we want to do is factor. And how we factor is we really kind of make an educated guess. If we're going to factor a quadratic, we know it has to break up into two binomials. The first term of each of those binomials, since we start with x squared, is going to be x and x. And now the only really hard part actually to think about is the last term. This last term is going to help us determine what goes here and here. And remember, that last term is the product of those two things. So we need to think of two numbers that multiply together to give us 20. And that's either going to be 1 and 20, or 2 and 10, or 5 and 4. Well, how do we know which one to do? Well, we can start guessing and testing if we want, just putting in a 1 and a 20. And we know that when we do first, x times x will give us the x squared. When we do last, 1 times 20, that'll give us a 20. But we need the outsides and the insides to help us make this negative 9. So what we do is we just multiply those two together and multiply those two together. See what we get. When we multiply the outsides, we'll get 20x. And when we do the insides, we'll get 1x. Can we put a 20x and a 1x together to make negative 9? No, we can't. And that means that these two are not going to be 1 and 20. So we pick another one. It's not going to be 1 and 20. Maybe it's going to be 2 and 10. When we do outsides, that'll give us 10x. And the insides will give us 2x. 2 and 10 can't make a 9 with 2 and 10. So That means that 2 and 10 are not going to be our numbers. So now we're down to the last pair, 5 and 4. And when we look at those, the insides will give us the 5x, and the outsides will give us 4x. 5 and 4 will give us a negative 9. If we do it right, we would need the 5x to be negative 5x, and the 4x to be negative 4x, in order to get the negative 9x. So that means we would need negative 4x, negative 5x, and we're done. The more you do this, the quicker that you get at it. If we wanted to FOIL x squared plus 4x minus 12, we know it's going to factor into x and x. And now we look at those pairs for 12. It's either going to be 1 and 12, 2 and 6, or 3 and 4. And just scanning the pairs, 1 and 12, that doesn't make 4. 2 and 6, now we can make a 4 out of that, and we can't make it with a 3 and a 4. So that means our numbers are going to have to be 2 and 6. Well, how do we make plus 4 with a 2 and a 6? Well, we need plus 6x and minus 2x. So the 6 needs to be positive and the 2 needs to be negative, and there's our two factors. Remember, we have special products. If we look and we see that we have a quadratic, that's something that has an x squared in it, but it only has two terms, that's it could be the difference of two squares. And that's what's happening here. Because we'll have x squared, that's perfect squared, minus, that's the difference, and 36, that's another perfect square. We can just say our answer is going to be x plus 6, x minus 6. We may also have a perfect square situation. Maybe you don't recognize it right away, so you start to factor it. X and x, then 9 is either going to be 1 and 9 or 3 and 3. Well, the only way to make a 6 is with that 3 and 3. So 3 and 3. We would need plus 3x and plus 3x to make 6x. So that is obviously, since we're taking the same thing and multiplying it by itself, that makes a perfect square. The thing that's going to help us to solve quadratic equations is the zero product property, which says if we're multiplying two things together and they equal 0, that means one of those two things have to be 0. You know? When we have a quadratic that's factored, what we're doing is we're taking this one thing and multiplying it by this other thing. And when we multiply them two things together, they equal 0. That means that one of them has to equal 0. And we can use that idea to help us solve this by saying, well, x plus 30 equals 0, or x minus 5 is equal to 0. If x plus 30 is equal to 0, that means that x equals negative 30. And if x minus 5 equals 0, well, we add 5 to both sides. Oops. And that means that x is equal to positive 5. And there we get our two solutions to the quadratic. So, what if we have a nice quadratic right here that's not factored? Just x squared plus 7x minus 30 equals 0. We'll go ahead and factor it. Factor x squared into x and x. Now that 30 is either going to be 1 and 30, 2 and 15, 3 and 10, 5 and 6. Well, 1 and 30 doesn't make 7. 2 and 15 can't make 7. But 3 and 10 can. If we have plus 10 minus 3, that makes a positive 7. So there, it's factored. Once it's factored, and the product of those two factors equals 0, we could say either x plus 10 equals 0, or x minus 3 equals 0. Now solve each of those. X equals negative 10, or x equals 3. Try another one. X squared minus 11x plus 30 equals 0. Factor it. X into x equals 0. And when we think about those factors again, well, that doesn't make 0, or negative 11. That doesn't make negative 11. That doesn't make negative 11. But 5 and 6 does. And we would, to make negative 11x, we need negative 6 and negative 5. So there We have it factored. Set each factor equal to 0 and solve. There's our solution. We could have one of those special products. Here we have the difference of two squares, so it's easier to factor. X plus 9, x minus 9. Set each factor equal to 0 and solve. Either x equals negative 9 or x equals positive 9. One more. Here it's not equal to 0. So before we can even start solving this, we need to get it equal to 0. So we add 4 to both sides. Then it equals 0. Now we can factor it. When we look at the factors of 4, it's either 1 and 4 or 2 and 2. Well, 2 and 2 is the only way to make negative 4, if both of them are negative. And we see that we have this perfect square situation happening again. But all that means is that either x minus 2 equals 0 or x minus 2 equals 0. So we really only have to solve one of those. So x is just going to equal to 2. And here we'll have a quadratic that only has one solution. It actually has two solutions, just both of them are the same.